So in this video we're going to balance oxidation-reduction reactions in basic media. So I have a reaction set up here. I have the oxidation numbers for each one of the species. So the next thing we're going to do is figure out what's being oxidized and what's being reduced. So the chromium is going from +3 to +6, so that's going to be oxidation. The chlorine is going from +1 down to 0, so that's reduction. So we put the oxidation things together, so we'll put that right in the center here. So we have the CrOH3 going to CrO4 2-, and the other thing we have ClO- going to Cl2. All right. Just like with acidic media, we have to do the first step for balancing. Actually, we balance all the elements that are not oxygens or hydrogens. So we use this color here. Here's the chromium. There's one of each on both sides, so we don't have to balance that. The chlorine, we see there's 2 here, only 1 here, so we'll put a 2 there. The next thing we have to do is balance all the oxygens with waters. So let's see how many oxygens we have. We have 3 here, and there's only 4 on that side, so we're going to have to add 1 extra water over here. So we'll use the blue for that, which makes sense since blue is often attributed to water. Now down here we have 2 oxygens because you have to multiply the coefficient by the number of oxygens that's in the formula. So we have to have 2 waters over here because we don't have any oxygens. So that's that. Next, we balance any of the hydrogens with H+ ions. So I'll use my yellow chalk for that. Well, I see how many hydrogen ions I have. Well, I have 2 + 3 is 5. I have nothing on this side, so I will add 5 H+ ions there. Here we have 4 hydrogens. There's nothing on this side, so we're going to add 4 H+ ions here. So that takes care of that. Well, the next thing we do is figure out the number of electrons that we have present that we will need to add. Now, if it's for oxidation, we'll add it on the product side. If it's reduction, we add it on the reactant side. Just again, remember, reduction, reactant side. So we use the pink chalk for that. We have 0, 0, -2, +5. So we see that we have 0 on this side, we have +3 over here, so we have to drop this side down so it equals out, so we have 3 electrons, and now both sides are equal. What about this side? Well, we have +4, 2 times -1, that's -2, 0, and 0. So we have overall +2 on one side, 2 on the other, so we have to have 2 electrons to get this to be equal. All right, so that's that part. Now what's different here now is we have to add OH- ions to neutralize any of the H+. And what we add to one side has to be the same as the other side. So I'm going to use this lighter orange chalk here to do that. We see we have 5 H+ here, so we have to add 5 OH- here. Same to this side. Again, what you do to one side, you have to do to the other for this, to neutralize. A lot of times with these reactions, you'll have OH- at the end. Not all the time, but when you balance it out, you might have that. With the acidic media, you'd have H+. So we have 4 H+ here. So we have to add 4 OH- on this end, and the same over here. All right. Now what we'll have to do here is multiply one or both reactions to equal out the electrons here. Well, we see we have 3 here, 2 over here. So what I'm going to do is I'm going to multiply this whole thing by 2 and this whole thing by 3. So that way the electrons will balance out. Now the next part is when you're actually adding all the electrons together and all the reactants and products and all that. The one thing you have to recognize is that there's 5 H pluses and 5 OH minuses. You can combine those together to make waters. And then you would multiply, of course, all of this through by whatever the coefficient happens to be. So, in other words, those get submitted together to make 5 waters. Likewise over here, now it's getting a little messy, but there's 4 waters that will be formed over here. So we're going to have one big long equation here, and then we'll just simplify it out. So anyway, we have 10 OH minuses. Again, what we're doing here is we're adding all the reactant stuff together, multiplying through if need be, and then we'll have the product stuff. So we have 10 OH minuses. We have 2 waters, 2 CrOH3, plus down below here we have, don't forget these are waters, so we have 12 waters. We have our electrons here. Sometimes that gets mixed up there, so make sure we have that. We have 6 electrons, and then we have 6 ClO minus. Product side, we have 2 CrO4 2 minus. And then we have, again, we have the waters here we have to worry about. So we have 5 times 2, that's 10 waters. And then we have 6 electrons. I'm just going to continue it down here. We have 3 Cl2 and 6 waters and 12 OH minus. So it's a lot more involved than the other one because we have all these OH minuses and waters and such. Now we still want to simplify this and then rewrite the equation, which I'll put on the other board. But let's simplify first. Well, we see we have 10 OH minuses here. We have 12 over here. So we get rid of these, and we put a 2 there. Waters, well, we have 2, and here's 12. That's 14 waters. We could have added them together and then put it down here, but it's a little bit easier to see it this way. Here we have 16. So all the waters will disappear here. And so again, we have 14. We have 16 over here. That's 2. Electrons have to go away too. So then on the next board, we'll just simplify this. So we're going to simplify the equation I just crossed out the various species for. So we have 2 CrOH3 plus 6 ClO minus goes to 2 CrO4 2 minus plus 2 waters, 3 chlorines, and 2 OH minus. Now the other thing we need to do here is to check to see if charge is conserved. In other words, the grand total charge on both sides should be the same. So we have 0, minus 6, we have minus 4, 0, 0, minus 2. So minus 6 overall, and we're all set.